Good day, sir. We are the group 9 and 10, and we're going to discuss about Chapter 8 entitled Data Analysis, Interpretation, and Presentation.
The aims for this lesson are to help you understand the difference between stories and numbers in data, to teach you how to look at information from surveys, interviews, and observations, to show you helpful computer tools, and to point out common mistakes to avoid when you analyze and share your results.
First, I'm going to discuss about quantitative and qualitative. Quantitative data expressed as numbers. Examples include the number of students in a class, the price of a stock, or a person's height. Qualitative data, difficult to measure sensibly as the numbers, count number of words to measure dissatisfaction. Qualitative data, they are often gathered from interviews and focus groups, personal diaries, and lab notebooks, maps, photographs, and other printed materials or observation. Quantitative analysis, numerical methods to ascertain size, magnitude amount. Quantitative analysis examples include calculating the average income of a group, analyzing stock price trends, and using web traffic data to see which pages are most visited. Qualitative analysis expresses the nature of elements and it represented as themes, patterns, stories. A common example of this is analyzing customer feedback on a new product by reading through open-ended responses, identifying and coding recurring comments like ease of use or design, and grouping these codes into themes to find patterns. Be careful how you manipulate data and numbers. Second, simple quantitative analysis. Average. Average is a single value that summarizes or represents the general significance of a set of unequal values. May dasya tulun apart which are mean, median, and mode. Mean, add up values and divide by number of data points. Median, middle value of data when ranked. And mode, figure that appears most often in the data. May dasya nga di tulun na figure sa ubos. Kita nala niyo, asya to na pinaka-example. Percentage. Be careful not to mislead with numbers, and graphical representations give overview of data.
So now, let's proceed to visualizing log data. So in figure 8.6, interaction profiles of players in the Catena. This figure is structured exactly the same as figure 8.7, but it shows interaction data per players in a different in-game location, which is the Catena. So the y-axis is gesture as player sent, while the x-axis is gesture as player received. So the bubbles represent a player of a group of players. Similar to the starport, the greatest concentration of bubbles is in the lower left corner, meaning most players still had low social activity in the Catena. However, the overall spread of dots seem slightly less dense, and the high interaction players are fewer than the starport, suggesting the Catena might be slightly less active social hub compared to the starport. In figure 8.7, which is the interaction profiles of players in the starport, this image is a scatter plot that shows how frequently players communicated with each other in a specific location of a massively online game called the starport. The x-axis show how many communication actions a player received from each other, while the y-axis show how many communication actions a player sent to each other. Each circle represents a single player. The size of a circle represents the number of players with that specific combination of gesture made and received. A larger bubble means more players had that interaction pattern. So now let's proceed to web analytics. So as is shown in this figure, which is the login frequency histogram. This graph analyzes how often different groups of users log into the game. It is a histogram that plots the percentage of a logins, which is the y-axis, and the x-axis, which is the against the time interval between logins. This shows that a significant portion of the player base has a highly regular, scheduled login pattern, open day to day. The pink and yellow lines stay very low and don't show the high spikes. This suggests that the most active user logs in more randomly or continuously rather than strictly once every 24 or 48 hours.
Under simple qualitative analysis, recurring patterns or themes, looking for ideas or topics that keep coming up in the data. Emergent from data. The main themes are discovered by looking at the data itself rather than being decided in advance. Categorizing data. Organizing the information into different groups. Categorization scheme. The groups or organizing data can be created as you go, or you can use a predefined set of groups. Lastly, looking for critical incidents. Paying special attention to important or surprising events that stand out. So next is tools to support data analysis. A spreadsheet. A simple familiar tool like Excel for basic organization and charts. Statistical packages, SPSS, software for complex number crunching and statistical tests. Qualitative data analysis tools, specialized software to help organize and find themes and text-based data like interviews. CAQDAS, networking project, a central online resource for information about qualitative data analysis software. In theoretical frameworks for qualitative analysis. Basing data analysis around theoretical frameworks, using established theories gives you a smarter, more powerful lens to interpret your data. Grounded theory, a method where you build a theory directly from the ground up based on the data you collect. Distributed cognition, a framework that studies how thinking is shared across people, tools, and the environment. Activity theory, a way to analyze human behavior by looking at the entire context, including people, their goals, and the tools they use.
Grounded theory. The slide explains grounded theory, a research methodology used to generate theories based on the scientific analysis of data. Instead of beginning with an existing theory, researchers allow theory to emerge from data itself. Grounded theory uses a categorization process called coding, which happens in three levels. Number 1, open coding, identifying key categories or concepts within the data. Actual coding, linking these categories to subcategories to understand relationships. Selective coding, integrating the categories to form an overall theoretical framework. Researchers are encouraged to draw from their existing knowledge and theoretical backgrounds to deepen the analysis. Codebook used in grounded theory analysis. This slide shows an example of a codebook, which is a tool used by researchers to organize and track codes during analysis. A codebook typically contains categories and subcategories, definition of each code, rules for when to apply each code, sample questions from the data. The shown code books comes from a study analyzing citizen science motivations, demonstrating how researchers document and structure their coding decisions to maintain consistency. Excerpt showing actual coding. The slide presents a diagram illustrating actual coding where codes identified during open coding are connected to show relationships. In the example, the main category is technology. Subcategories such as intermediate, strategy, triggers, relationships, identity building, and team learning are linked to broader themes
such as purpose, accessibility, and ownership. This level of coding helps researchers understand how categories influence each other, the underlying structure of a phenomenon, what factors cause of or connect concepts. Distributed cognition. These concepts views cognition as not only happening inside a human mind but shared across people, tools, technology, environment. In this perspective, all components work together as one extended cognitive system. Distributed cognition is commonly used in studies involving collaborative work, learning environments, and technology supportive tasks. Example for better understanding. Example of grounded theory coding. Imagine you interview students about why they prepare online classes. Samples responses may include, I can study at my own pace, it saves me money on transformation, sometimes I feel isolated. Open coding, flexibility, cost saving, isolation, actual coding naman, group codes into relationships, flexibility, learning experience, cost saving, practical benefits, isolation, challenges, selective coding, formulate a theory. Students choose online learning primarily for flexibility and reduced cost, but it may negatively affect their essence of connection. Example of distributed cognition. A hospital emergency room uses a distributed cognition. Doctors and nurses, people. Patient, charts, artifacts. Monitors and medical devices, technology. Hospital layout, environment. Together, these elements support rapid decision making. The thinking is shared across all components, not just individuals.
Distributed cognition is the collaborative process where knowledge is spread across people, tools, and environment to enhance understanding, decision-making, and communication of data insights. Activity theory is a framework where human interactions with data, like analyzing, interpreting, presenting, are seen as a goal-driven activities, shaped by tools, example, software, community, example, team norms, and rules emphasizing the context and collaboration that influence outcomes. The individual model focuses on one person processing data, collecting, analyzing, interpreting, and presenting insights largely solo, relying on their skills, tools, and cognition with minimal external collaboration.
This figure shows Engstrom's activity system model, an expanded version of the basic theory triangle, used as a framework to analyze complex human interactions and social transformation. This third-generation activity theory views collective, object-oriented activity as the primary unit of analysis. The model is typically visualized as an expanded triangle or a system of 6 interrelated components. The first one is the tools, sometimes referred to as mediating artifacts, which both external material tools and internal symbolic tools used by the subject to act on the object. The next one is the subject, the individual or group whose viewpoint is the focus of the analysis. The next one is the object, raw material or problem space toward which the activity is directed, which is transformed into an outcome. The object provides the motivation for the activity. And then the next one is the explicit and implicit norms, convention, and social regulations that govern the activity within the community, which is also known as rules. The next one is the community, the broader group of people who share the same general object and who participate in the activity system. And then we have division of labor, the way tasks, responsibilities, and power are distributed among members of the community. The last one is the outcome, the desired goal or result of the activity system. In presenting the findings, the best way to present your findings depends on the audience, the purpose, and the data gathering and analysis undertaken. Only make claims that your data can support. The graphical representation may be appropriate for presentation. The other techniques are rigorous notations using stories, to create scenarios and summarizing the findings.
The summary shows that your analysis depends on what you gather. You can get stories or numbers from any method. People often use percentages and averages in design, but there are three different kinds of averages that can give different results. Using certain theories can help you understand your data better. Most importantly, always present your findings truthfully and don't exaggerate what you found.